Today we are going to be looking at integration by paths. Okay, it's just a way of integrating a function that looks a little bit like this. Now let me write down the formula and then I'll tell you where it comes from. Okay, so if your function is written like this, so you've got one bit of the function that you identify as u, and then you have another bit of the function that you identify as dv by dx. And if you want to integrate that with respect to x, you are going to get this. Okay, now this formula is given in your formula book, and I just want to go through where this comes from. Okay, so this actually is the undoing of the product rule that you learned in differentiation. Okay, and I'm going to show you how. So in product rule for differentiation, you learned that if you were to differentiate a product of two functions, you would get derivative of one multiplied by the other, and you would then have you would then differentiate the other function and multiply it by f of x, for example, here. Okay, so this is what you learned in differentiation. Now what if you were asked to integrate this? Okay, so if you were asked to integrate this, for example, or if I integrate this whole thing, this is what is going to happen. Okay, and then obviously the integration and the differentiation, they kind of cancel out, don't they? So then I'm left with f of x gx again. Okay, because I've just undid my differentiation with the integration. Okay, and I'm going to leave this as it is, and I'm going to go to the next step and show you what actually happens. Okay, so now what I'm going to do is I'm just going to rearrange it, okay? Because remember, I'm trying to show you that the integration by parts formula should look something like this. Okay, so I am going to rearrange this. Okay, so I'm just going to rearrange a little bit. So I'm going to bring this over. Okay, so that didn't change anything. And now what I'm going to do is I'm going to go and put it back into this form. Okay, so I'm going to call my u f of x, and I'm going to call my v g of x, and then du by dx is f dash x, so that means du is f dash x dx, and dv by dx is g dash x, that means dv is equal to g dash x dx. And now I'm going to plug all of these into here. Okay, so if I do that, I'm going to get uv minus, and then I have f dash dx, that's du, and gx is v, so I'm going to write v multiplied by du equals integration sign, and now I have g dash dx, which is dv, and f of x is u, so that's going to be u dv. Okay, and that's actually what I'm trying to get to over here. Is just written the other way around, so I'm going to just flip it over, and I will have u dv equals uv minus v du. And because I am integrating, I am going to have to just yeah, actually that's it really. So I've got what I wanted. Okay, I've got what I wanted, because look, dv by dx times by dx is actually u dv, uv stays as it is, and then v du by dx multiplied by dx actually doesn't do anything, but it just gives it in a nice form, because the thing is, because you're integrating, you've got to have a dx there. Okay, so all I've done is I've divided by dx and multiplied it by dx, which actually doesn't do anything, okay? But it just gives us, it gives it to us, okay? So this is where the integration by parts formula comes from, but it's given to you in the formula book. Alright?